Lesson 8.4, proving triangles similar. This is a big chunk of geometry. There's going to be properties that prove triangles are congruent, which means exactly the same, and this one, triangles are similar. So remember, similar means that they can be dilated, but they still have to be proportionate. So there's 3 different ways to prove it. First one is angle, angle. I'm going to write that. So remember AA, not like an AA meeting, but angle, angle. That one is saying that 2 pairs of corresponding angles are congruent. Remember we talked about that dilating an object does not change the angles ever, ever, ever. There's still the same amount of opening here, no matter how big or small I enlarge or shrink the triangles. And so if I know that, let's say angle B here is, what does that look like? 70 degrees. And then Z is 70 degrees. And I know that A here is 30 degrees and this one's 30 degrees. I have enough info to say that yes, there are similar because I know there's 180 degrees here. There's 100 of it, so this must be 80 and this must be 80. So really I only need to know 2 angles because then the third one automatically is the same and therefore making the triangles similar. I could not say that they're congruent by that, but anyways, so that's what I'm looking at, is seeing that, okay, angle, let's just go B is equal to angle Z, and angle A was equal to angle Y. Okay, the second way you can prove that 2 triangles are similar is by side, side, side. All 3 pairs of corresponding sides are proportionate, so you want to make a proportion out of them. So looking at these triangles, you can see they're in the same orientation here. So let's say I have 4 to 40, so I'm going to make it a fraction. I would see if that's equal to 5 to 50, and see if that's equal to 6 to 60. Some of them you can just look at and tell that this is 1/10, 1/10, 1/10. Yes, because it all equals 1/10. All right, and then side, angle side is the last one. SAS. 2 pairs of corresponding sides are proportionate, like what we talked about here, just 2 of the pairs, and the included angles between them are congruent. So it's kind of like a mix between these 2. It has to be the angle that's included between the sides. So it's where this side and this side meet, it's this angle. Where this side and this side meet, it's this angle. Okay, so I would check and say, okay, here's my short side, 2 to 3. Is that proportionate to S4 to 6? Yeah, because that would simplify to 2/3. So yes. And then I see that these angles here are congruent. So yes. So let's try some using those 3. So number 1, determine if triangle FGH and IJK are or are not similar, and if they are, state how you know. It's just which property here. It's kind of hard to tell which side goes with which, but what I like to do is just go in order. So see how 20 and 20 are the same here, just as 30 and 30, and then here's my bigger side. And also, I guess I should state before that, I don't have any angles, so I know I'm not going to be using angle, angle, and I'm not going to be using side, angle, side. It has to be from the side, side, side. So we're just seeing if they are proportionate. So I'm going to start with 20, and then I'm going to go smaller side over here is 30. So I went this one, and then 20 to 30 again, which obviously these 2 are the same ratio. And then I need to see if 26 is the same thing as 39. Okay, let's say I'm lazy, I don't want to even think about it. I would just divide these. 26 divided by 39 is that decimal. Well, what about 20 divided by 30? Yes. That's actually 2/3. So they're all this ratio of about 0.67. So yes, but if they wouldn't have all equal the same thing, then no, they're not similar. So I'm going to put yes by side, side, side. All right, number 2, same thing, figure out if they're similar. This time I have angles. So I want to look, and I've also got sides here. So I see the side of 13, this PQ, which is ordered first and second letter, and then ST. So PQ and ST should be corresponding. So I'm going to put 13 over 39 is equal to, I'm going to put PR, which is first and third, and then SU is this one. So I'm going to put 16 over 48. You can just divide them. That should be a third, and 16 over 48 should also be a third. So yes, these are proportionate, so check. The angle between them, is it congruent? Angle P is equal to angle S, check. So this is yes, they are similar by side, angle, side. And then one more. I kind of look at it to see what information they're giving me. I can't make anything up, right? So here I only see one pair of sides that I have a measurement for. So I know I don't have enough info to prove by side, 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 or even side, angle, side. I have to have two sides there. So I'm really just looking angle, angle, does it work? So I see a 60 and a 67. I'm going to go ahead and figure out what's this other angle. So 180 minus 60 minus 67 is 53. And then this would be 180 minus 54 minus 67 is 59. So I had the 67s the same, but these two and these two don't match. So no, they are not similar. But if I would have had two pairs of angles the same, that means the other one would have been the same and I would have said yes.